Okay, today we're going to be talking about solar thermal and photovoltaic energy for residential buildings. I'm Cicconi, and we also have Paul, Homan, and Niki Glass speaking. First, it's important to go over what solar thermal energy is. So solar thermal energy is heat energy transfer from the sun. Solar thermal power cells capture this heat energy from the sun and generate power to heat the water in households. And just to explain what solar thermal cells are and how they work. First, solar thermal cells must absorb the emitted thermal energy. Mirrors on the solar cell reflect the thermal energy into a receiver. This collected thermal energy heats up a designated fluid to produce steam. This steam then powers a turbine, thus generating electrical power. This is more seen in power plants. In households, the fluid is heated up just for water heaters and hot water for the house. And then this kind of shows what happens in a household. We start at the cold water feed. This enters a tank, which then goes up into a pump. The pump then reaches the solar cell, which is normally mounted on the roof of the house. The energy from the sun heats up the fluid, which then heat goes back into the tank and then heats the water in the household. Now talk about photovoltaic energy. Photovoltaic energy is the radiant light energy emitted by the sun. Photovoltaic cells are substances that work to capture and concentrate this light energy and convert it into electricity. This practice is commonly seen in solar panels, which line the roofs of many households today. Just to go over how they work, as previously mentioned, they convert energy from the sun into electrical energy. So basically, this is kind of like the solar panel we talked about with solar thermal energy, only in this case using light and converting it into electrical energy instead of heating water. Sunlight is composed of photons, and these particles carry solar energy. First, the photons are concentrated to maximize the solar energy input. Fresnel lenses are used to concentrate the photons into one tight beam to make it more efficient. After passing through the lenses, the beam hits the solar cell. The solar cell is made up of semiconductor material like silicon. The semiconductor absorbs this solar energy, and this increased energy input causes electrons within the semiconductor to move. These displaced electrons cause a charge imbalance within the solar cell. And then this charge imbalance leads to a voltage differential, which is seen in a common battery. From this battery, current flows, and then this is what powers electrical appliances and fixtures in households. And then the efficiency and electrical power generated is amplified as more cells are strung together and more solar panels are added. So this is a diagram of how a photovoltaic cell works. You can see the photons hitting the cell, then creating an imbalance with the electrons. This generates a voltage imbalance and then current flow.
So I'm going to go over a few examples of residential applications. So the first one is a solar thermal energy example, and that is a hot water heater. A hot water heater uses sunlight to heat water and stores it in a tank to be used inside of the building. Active hot water heaters have two variations, which each application depends on the surrounding climate. The direct circulation water heater directly heats the water itself and sends it into the tank to be used in the home. This type is typically used in warmer climates that don't reach freezing temperatures, where on the other hand an indirect circulation water heater will heat antifreeze liquid, which runs to the hot water tank and works as a heat exchanger to heat the water. This application is better for colder climates where the water would freeze if you use the direct circulation. Another example of residential application in terms of photovoltaic cells is JLM's new product that has been installed on more than a dozen homes in the Phoenix area. It works by pairing solar panels with an energy storage device. The energy storage device is installed underneath the solar panel that it interacts with, and during the daytime the solar energy charges the battery and also delivers energy to the building as needed. During the nighttime, the battery source is used to power the home using the energy harness during the daytime, which delivers the remaining energy to the building. And lastly, another example of photovoltaic energy comes from the National Renewable Energy Lab. They're currently working on a project that turns windows into solar panels at certain times of the day. When the temperature of the window reaches a certain point under direct sunlight, the window darkens and converts to a solar panel. So this technology acts as a standard window by keeping the heat out of the building, as well as harnessing the energy from the sun that hits the window. The National Lab has reached a 11.3 efficiency on these windows and continues to test the repeatability, because this repeatability has been poor. Once the technology is marketable, it will be installed in residential settings as well as car windows in order to power electric and hybrid vehicles.
So solar thermal energy has several advantages and disadvantages when it comes to being compared to energy developed by either fossil fuels or photovoltaic energy. As compared to energy that's generated using fossil fuels, solar thermal energy reduces energy costs, it leaves less of a carbon footprint, and then compared to photovoltaic energy, it's cheaper to install and requires less space. One of the disadvantages of solar thermal energy, and this applies to photovoltaic as well, is that the energy produced is dependent on the sun or the weather, so the energy produced in the summer varies greatly from the energy produced in the winter. The other main disadvantages are that it's only capable of heating water, and it usually needs annual maintenance, as well as it does require a little bit of extra space for that hot water cylinder. Moving on to photovoltaic energy, the advantages when compared to fossil fuels are similar as before. When compared to solar thermal energy, it's quieter, more reliable, and it fits in unused spaces like the roof of a home. Because it produces electricity, there is more flexibility with its uses, and it usually has enough efficiency to power a home. The disadvantages to photovoltaic energy are that it does take up more space, it's more expensive, and like solar thermal energy, the electricity produced is dependent on the sun. In conclusion, both of these types of devices work to harness the sun's energy to either produce electricity or heat water. Solar-powered energy has been increasing in residential households over the past 10 years and is expected to continue. And so far, research groups and solar companies are working to improve efficiencies and lower installation costs. And then these are our sources. Thanks for listening.